Today we're going to talk about translating points as well as translating functions. So now we're going to talk about 6 main translations. So we're going to take a look at taking a function and shifting it up, down, left, right, and also some reflections. So let's first start off with taking a point and translating it. So let's say my point is x, comma, f of x. Okay? Now, if I want to move that point up, if I want to take that point and move it up in the coordinate plane, what part of that coordinate is getting affected? That would be the y-coordinate. So if you want to move a point up, you're going to have x, comma, f of x, and then plus whatever number you'd like to add to that, right? So moving a function up is going to add something to the y's. Similarly, if you want to move a function or a point down, you're going to be subtracting something from the y's. Okay, if you want to take a point and move it down in the coordinate plane, you're going to subtract something from the y's. Okay? Now, if you want to move a point to the right, what part of the coordinate is getting affected there? That would be the x. So if you want to move a point to the right, you're going to add something to the x value, and your y value will stay the same. Left is also similar. You're going to take away a value from the x, and your y is going to stay the same. So hopefully you looked at that in Algebra 1, taking points and moving them around the coordinate plane. Now this is going to be a little bit different when we're looking at functions themselves. All right? So I have a function. My function is f of x. Okay? Now, if I want to take my function and move the entire function up, it's going to look very similar to moving a specific point up, because all I'm going to do there is just take the function and add whatever I would like. And then similarly, if I want to move a function down, I just take the function and subtract. This is a little bit different when we're talking about moving from left to right. So I'm going to write down notationally what you're supposed to do, and then we're going to talk about it. If I want to move a function to the right, that's affecting the x coordinates. So I have to do something on the inside of those parentheses. So if I want to move to the right, I actually have to do x minus whatever that number is when I'm talking about function notation. And for the left, it's actually plus. Okay? So of course the question in your mind is, well, why is that opposite? Why is it opposite of what I really want to do to the point? And the answer to that question is that, think about it, you don't want the y value of that point to change. So what's happening here is that if I want to take this translation here, here's f of x minus my translation. If I want to take that translation and input the point that I have, so I'm going to replace this x with the translated point, and the translated point is x plus that value. And then I subtract that value. What happens here? Well, those values actually end up canceling each other out, and you get f of x. And that's what you want, because you want those y values to stay the same. So you have to do the opposite inside those parentheses because you want to maintain that same y value. So if I take a look at it for the left here, I'm going to add on the inside of those parentheses, because if I were to input x minus that number, because that is my translated to the left point, and then add that point, what I'm going to be left with here, my output is still f of x, and that's what I want. I'm trying to maintain my f of x. Okay? And then just in here, we're going to put, if I want to move up, I do f of x plus a number. That's pretty self-explanatory because those x values in these cases are staying the same. Okay? Let's take a look at a reflection. Now, if you want to reflect a function over the x-axis, so here's a little sketch here. Let's say that my function is up here. if I want to reflect that over the x-axis, it's just going to basically flip upside down. It's a terrible drawing, but you understand. You're going to flip your function upside down, so all your x values stay the same, but your y values are opposite. Okay, so if you want to make your y values opposite, you just have to put a little negative sign in front of your f of x, and that will reflect over the x-axis. Let's do another sketch here for the y-axis. Let's say I have a function over here, and I want to translate it over the y. It's going to reflect this way. Notice all your y values are staying the same, and your x values are opposite. So you're just going to have to put a little negative sign on the inside of that function. Okay, so let's take a look at an example. All right, so here I have an equation, y equals the absolute value of x. And I'm going to take that function, I'm going to do all of these shifts. So keep in mind that there's a couple of ways that you can write these. Now, in this case, since I'm actually giving you what the equation is, I'm giving you the fact that it is the absolute value of x. Okay, our third example is going to be when I'm just going to give you a picture. So in this case, if you want to shift something to the right, remember that you're thinking about the inside of the function. Okay, so I'm going to be placing a translation on the inside of that absolute value bar. And remember that to the right is affecting an x value, and I always want to do the opposite. So inside of there, I'm going to have x minus 3. If I want to move up, remember that I'm talking about the outside there. I'm talking about changing the y value, so nothing changes on the inside, and I just add 5 to the outside. Okay, for left, remember again, we're going on the inside of the function because we're changing the x values, and we're going to think opposite in this case, so I'm going to add 8 on the inside of the absolute value bars. For D here, I've got 2. I'm moving to the right and down. Okay, so I've got a minus 2 on the inside of the bars and a minus 4 on the outside of the bars. Keep in mind you cannot manipulate that in any other way because the negative 2 and the negative 4, they are in separate places of that function, so you leave it exactly the way that it is. E, we have a reflection over the x-axis, and we're going to move up 1. Okay, so for a reflection over the x, I put a negative in front of the function, and up 1, I add it. Okay? All right, let's take a look at a picture. So here, I've given you the picture. So you're going to want to take this picture and shift it according to this function notation here. So if I look up here, this is telling me that I want to move left 2 and up 3. Okay? So there's a bunch of different ways you can do this. I personally like to make a little table. So if I look here, I've got the point 0, negative 4. I've got 2, 0 here, and then I have 4, 4. Okay? Now, if I want to move left 2 and up 3, that means that my x values, I'm going to take away 2, and with my y values, I'm going to add 3. So when I make a table for my new function, I just want to make sure that I call it something different, right? Because it's not f of x, it's a translation of f of x. So now these points are going to be negative 2, negative 1, 0, 3, and 2, 7. Okay? So I'm going to plot these. It's going to look a little bit different from what I originally had, but that's just because the scale on this coordinate plane is a little bit different. But every time you do this, you want to make sure that you try and keep the same shape that you had originally. So I'm going to do my best here. So it kind of curves up a little bit, maybe flattens out when I get here, and then curves up again. And there's my translated function. All right, so in class, we're going to be working with shifting things, writing it down with proper notation, and good luck.